Alright guys, 7th grade, this is March 30th, this is Monday. So I hope y'all had a good little break here from your math, but we got to get back to get it started. And so I miss y'all, miss all our cutting up and stuff. And so today is going to be a longer lesson, and so you need to just make sure we actually get the work done because this is very important. And what's going to happen is this is going to build on this moving up into other grades. And so today is going to be a little bit more work for y'all to do, but as long as we get this first part out of the way, it should move through very smoothly. And so this is on page, in the packet I gave you, it's page 402. It's the very first page. And so what we need to do is I'm just going to go through a few terms here with you. And so just kind of follow along and listen to what I'm saying. And so the first term is a like term, and that is a term that have the same variables raised to the same exponents. And so that sounds a little bit complicated because we haven't really done a whole lot with exponents, but if you've noticed, I've written some up on the board here. So the first one is 2a squared and negative 8a squared. And so what you need to pay attention to is that this a squared part, notice how the a squared is exactly the same. And so I know we like candy, and so the easiest way I've kind of learned this when I was in school was to think about objects. And so if you had 2 Kit Kats and you wanted to add 5 Kit Kats to it, notice that obviously that would be 2 plus 5, so that is 7 Kit Kats. Now, notice you don't do anything to the Kit Kat. The Kit Kat stays the same. The Kit Kat doesn't become a Snicker bar. The Kit Kat doesn't become Kit Kat, Kit Kat. It just stays Kit Kat. And so what happens is you're not going to mess with the actual variables. You're just going to count them if they look the same. So notice up here, I have 2a squareds and I have a negative 8a squareds. And so the a squared is like the Kit Kat. It stays the same. But we're just going to count how many of them we have. And so you have 2a squareds and then you have negative 8a squareds. And so you're just going to count the a squareds. Okay? For 5x and 12x, notice you have the x that's the same. So the x is like our candy, what we're counting. And so you would just add the 5 and the 12. And so the first step in this is not even to do the counting, it's just to be able to identify what looks the same. What's the like term? And so again, like term is just a term that has the same variables raised to the same exponents. In other words, it looks exactly the same. And so if you notice this last one, it has 2 exponents on it, but they're exactly the same. It's a to the first, b to the first, exactly the same. A to the first, b to the first, exactly the same. And so those are like terms. You can think of it as apples if you're counting apples, oranges, candy, anything like that. Just you're counting the exact same things. You can't count apples and bananas. They're different. So it has to look exactly the same, and then you're just counting them. And so that essentially is the lesson. The only thing we're going to do now is actually look at it in a little bit more detail and actually count the stuff up. But as long as you can remember that we're looking for the exact same thing, x and x, ab, a squared, Kit Kat, then you've got it down. And so if you look in your book, basically since this is on video, what we're going to do, we're going to go through exactly how we do it in class. And so I'll do some, then I'll assign a few for you to do, and then I'll give you at the very end, you can actually work through the homework section. And so if you look at number 1, it says, determine if each polynomial expression is composed of like or unlike terms. And so a like term is something that looks exactly the same. So the a squared and the a squared. An unlike term is if it doesn't look the same. So in other words, an unlike term would be like if I had 2 x's and then I was trying to add 4 y's to it. Notice the x and the y are different. They're not the same object. They're not the same thing. And so you can't combine them. You just have 2 x's and 4 y's. That would be like saying I had 2 Kit Kats and 4 Snicker bars. You can't combine them. That's just what you have left. And so that would be an example of an unlike term. So those are unlike. These over here would be an example of a like term. So these are your likes. This would be an example of your unlikes. And so your likes, exact same thing. Unlikes, different objects, different variables, different exponents. All right, so normally I would ask if you have any questions on that. So that just kind of is where we, if you pause and just think about that for a second and make sure we're okay as we move forward. So moving forward, number 1 gives you, I'm going to erase this, so make sure we have that. If you need to rewind or anything like that. Number 1 says 9A plus 9B. Okay, so the first thing you're just telling if they're like or unlike. So remember, like, they have exactly the same variable, exactly the same exponents, they're exactly the same object, and then you're just counting how many of them you have. So here you have 9A, so that's an A. Think of that as an apple. 9B, you can think of that as banana. So you cannot combine 9 apples and 9 bananas. You can't get 18 apple bananas or any weird stuff like that y'all may try to do. It's just 9 apples, 9 bananas. That's all you can do. Those aren't like, so that is unlike. So see, once you get it down, it's pretty straightforward. Just look and see what you see. A, B, not the same, so it's unlike. If you look at number 3, I'm basically going to go through the odds like we normally do, and then I'll give us the evens to do for work for y'all to do. So number 3 says we have 5A plus 5AB. So again, just telling if it's like or unlike, so you're going to look at it and identify the variable and see if they're the same. So the first variable on this first term, this 5A, the variable is an A. So that means for it to be a like term, the next one has to be exactly the same. But notice it's AB, so our AB is different than just our A, and so that would be unlike term. So you would put unlike. All right, number 5, I'll just do it right here. So 5 says x squared plus 5x squared. So again, just telling if they're like terms or unlike terms. So the x squared, notice the definition said the same variable with the same exponent. So we can have exponents, that's fine, don't get confused with that. So now you're just thinking of it in terms of x squared, your object. Okay? Over here we have 5x squared. So x squared is our object. That's what we're looking at. Now, we have 1x squared and 5x squared, so the number's different, but the important thing is just determining if they're like or unlike. They just have to have this same object that we underline. So x squared and x squared match, so therefore that would be an example of a like term. So, up on the board right now I have an example of an unlike and a like. So the unlike, notice how the A is different than the AB, that's unlike. Then for your like terms, notice how our x squared is the same as our x squared. Alright, so at this point, if you want to pause the video in a second, what I'm going to have you do is do 2 through 6. Just do 2 through 6, and then I'm going to go through them with you. So 2 through 6, go ahead and pause the video right now, and do 2 through 6. Okay, so 2 through 6, number 2 says negative 5x plus 10x. Okay, so negative 5x plus 10x. So notice that what you should notice is that each is an x and an x, that's the same. So the first question you need to ask yourself is what is the object, what is the variable? So what are we looking at? We're looking at just an x and just an x. So number 2 would be an example of a like. Number 4, going through it, you have 6xy minus 5xy. So notice that it's an xy and an xy, so that would be a like. And then number 6, be careful with 6, just look at it. Remember, it has to be exactly the same for it to be like. So it had 10x squared y plus 10xy squared. So at first glance, they may look exactly the same, so you have to be careful, don't let it trip you. So x squared y is what we're looking for. So this has to be exactly an x squared y. This is an xy squared. So notice they flipped it. The square was with the x here, but the square was with a y there. Those are two separate, totally separate things. And so they have to match exactly. So this was number 6. So 6 would be an example of unlike terms because you have the x squared y does not match exactly with the xy squared. They have to match exactly. Okay? So for homework on that section, you will have 8 through 14. I circled them on the paper, and so that will be good for y'all to do at the very end. We'll move on to the next section here, but that'll be what you do for homework is 8 through 14 for that section. Okay? The next section on 13 through 23, if you're looking at the same thing, they're just wanting you to know if they're simplified. All simplified means is that you can't add them. So there's no like terms that you could add and combine together. So if you look at 15, it's 15. You have 8x plus 4x. And so notice these are like terms. You have the x and the x. So when you're dealing with simplified, not simplified, you're just saying, okay, can I combine these? If they're the same, you could combine them. And so 8x's plus 4x's we can combine because they're like terms. And so the 8x's plus the 4x's, if we actually did the addition, would be 12x's or 12x. So this right here, what they originally gave us, would be not simplified because we could combine them. So if you can combine them, if they're the same and you can combine them, then it's not simplified. If they're different, which means they're not like terms, they're unlike terms, then we can't combine them, so you just leave it. So that means it's simplified. So simplified means we can leave it. Not simplified means we can combine them. So if you look at number 17, 17 says b squared, 4b squared plus 9b. So notice again, look at the variables, see if they're exactly the same, see if you're dealing with the exact same object. We have b squared, so that means to match it, for it to be a like term, it has to be a b squared. But we're dealing with 9b on the other side. So 9b is not the same, the b is not the same as the b squared, which means they're unlike terms, which means we cannot combine them. And so if we cannot combine them, then that means it is simplified. That's as far as you can go with it. So that is as far as we can go. That would be our answer if we were working one through, because we can't combine anything. That's as simple as it can get. That's as far as we can go. So if they're the same, you can it's not simplified because we can combine them. If they're different, then that means it's as simplified as it can get. So first try to determine if they're like or unlike, and then that'll lead you to the simplified, not simplified. So again, simplified is when they're different and we can't combine them, and so that's as simplified as it can get. All right, so y'all can try 18, 16, and 18 right now. So go ahead and pause the video and do 16 and 18. All right, so 16 said it was 10y plus 10. So 10y plus 10. So notice that you're looking at the variables, so not the numbers, it's the variables. So look at the y, and over here there's nothing there. Which if there's nothing there, that means it can't be the same as the y, because it has to match the y. And so this would be unlike terms, which means that's as simple as it can get. You can't combine anything, so that would be simplified. So 16 would be simplified. All right, number 18, notice it says 3d minus 8d plus 5. So notice you have the 3d and then the minus 8d. So notice they're both d's, so that means we could combine them. So that means number 18 would be not simplified. So 18 would be not simplified, and 16 would have been simplified. So those two, you can go back through and make sure you got those right. All right, so for homework on this section, it'll be 20 through 22. Do the rest of those two. I circled it on the packet, so as long as you do all the circled ones, you'll be fine. So next sections is 24 through 38. It says simplify each polynomial expression by adding like terms. So all this section does is tells you to actually do the addition. So that's really the only step we're doing now. Is actually if they're like terms, you do the addition and you add them. So 24 says 4x plus 8x. So again, you're looking to see if they're the same object, the same variable. So you have x's and you have x's, which means they're like terms, so we can combine them. If they're like terms, you can combine. And so this section just says do that. So you're going to take the 4x's and add it to 8x's. So how many x's do you have is the question. And if you did that, you do 4 plus 8, and that tells us you have 12 x's. Notice I didn't do the x stays the same, you're just adding how many objects you have. You started with x's, and so you have an x in your answer because that's telling you what it is. So if I did 4 Kit Kats and 8 Kit Kats, that would tell me I had 12 Kit Kats. And so whatever this variable is, it stays in your answer. You don't do anything with it, you're just adding the object, you're adding the number of them you have. So the 4 of them plus the 8 of them gives you the 12 of them. So 12x. I'll do 25 as well. So 25 says 9z minus 3z. So you have 9z's and you're subtracting 3z's from it. So notice that they are the same. They're z and z, so we can combine them. And so you have 9 of them and you're subtracting 3 of them off. So how many do you have left? You have 6 left, and so your answer would be 6z. And yes, I put the slash through the z because that's what mathematicians do. So 26, I'll do it. So 11w plus 18w. Again, you're just combining the w's. So you have 11w, and it says we're adding 18w's to it. So notice they are the same terms, and so they're the same, they're w's, so we can combine them. And so it's 11 plus 18. So if you did that up, you would get 29. And so your answer would be 29w. Alright, so at this point you can pause the video. I need you to do 28 and 30. So do 28 and 30 by yourself, and then I'll clean it up and make sure we got them right. So 28 and 30. Go ahead and do that. So pause right now. Alright, 28, you had 4d's minus d, so you had 4d minus d. So the question is, are those like terms? Yes, they are, so we have d and d. So 4d minus d, you just do subtract them. So you have 4d's minus the d, that leaves us 3d's. And so that would be your answer, would be 3d. Alright, 30, you had 15x squared minus 14x squared. So notice the x squareds are the same. And so we can just combine those, and so you have 15 of them, and it says to subtract off 14 of them. And so when you do that, you'll have just one x squared left. So your answer for 30 would be just x squared. Alright, so what I need you to do is 32 through 38 there in that section. Now, down towards the bottom there, notice they add in, instead of just doing 2 terms, they add in 3 terms. So I'll do one of those real quick before we move on. But you're just adding 3 numbers instead of 2. And so like 33, it says 9x plus 4x minus 2x. And so again, the x's are the same, so we can combine them. And so now we're just adding 3 numbers, it's the only change. And so it's just 9 plus 4, which is 13x. And then 13x minus 2x's would be 11x. So it's just one more step, so there was one more number. So that's that section. The next section says write the terms of each polynomial in conventional order. I know this is, we're just trying to get through this, so just try to go through it. That first part should be easier, and this will kind of be the last real skill. So you have 9a, it says 6b plus 9a And so, again, conventional order, you have basically two steps here. The first step is just to make sure it's basically alphabetical. That's how we generally do it. So it has to make sure it's in alphabetical order, so we need to know our alphabet. And then in descending order based on exponents, so for this one, it's just alphabetical. So it would be 6b plus 9a, we would rewrite as 9a plus 6b. You just want it written in alphabetical order, so A comes before B. So we're going to rewrite it like that. It's not a big deal here. This is just the more proper form. So like on standardized tests or whatever, you would see it written like this instead of like how they had it. Just probably have to go through it. So there's that one. If you look at one like 45. So 45 says 12 minus g squared plus m squared. And so for this one, 12 minus g squared plus m squared, again, it needs to be in alphabetical order first, so we need to get it listed alphabetically. So g comes before m, and then numbers always go at the end if there is no variable attached to it. So g comes before m, so it'd be minus g squared plus m squared, and then the number just goes on the end. So whatever the sign is, you have to pull that with it. So notice it was a negative g squared, so that has to pull down. Notice it was a positive m squared, so that pulls down, and the 12 just goes on the end. So just list it alphabetical order and keep it grouped. So you can try at this point, do 40 through, well no, wrong one, yeah. So 40 through 46. So you can do those, listed just alphabetically, and then in descending order of the exponents. All right, so the last section is just a combination of all of it, and so these last 3 or 4 problems we do to end the lesson is just basically taking it all and throwing it together. And so if you look, this will be it. So if you look at 48, well, I'll do 49. So 49 says negative 5x plus 4 plus 18x. So again, we're just combining everything that we've learned so far today. So we're going to take, well, like terms we can combine. If they're different, you have to leave it. And so notice we have an x and an x, so we can combine those two. And so negative 5x plus 18x, or 18x minus 5x, would leave you with 13x. And then the plus 4 has nothing to combine. We can't combine the 4 and the 13 because the 4 doesn't have an x. So you can only combine the same things. And so your final answer just has that plus 4 on the end because they're unlike terms. You cannot combine unlike terms. So if it doesn't have the object with it, if they're not the same, you can't combine them. So that will be your final answer. Remember, alphabetical number goes on the end. So the 13x comes first and then the 4. Where's a good one we can do? We'll do 53. Do the last one we do in class here. So 53 will be 4p minus 16w plus 8w plus 3. The last one. So the 16w and the 8w we can combine because those are like terms. You always want to look and see what looks the same, exactly the same. So we have 16w's and we have 8w's. So those can combine because they're the same. This is a p and that's a 3, so we can't combine that with w's. It has to be a w. So 16, negative 16, because we have to do this sign. And so negative 16 plus 8 would be a negative 8w. Okay? Then I'm just going to rewrite for just the clarity of it. Alright, so that's what I have right now. Notice that I have 4 p's and 8 w's. Those aren't the same, so we can't combine them. Then we have just a number. That's not the same as anything, so we can't combine them. And so that would be our answer. The last thing to check is just if it's in alphabetical order. P comes before W, so that would be in alphabetical order, so that's called conventional order. And so that would be our final answer. So you combine what looks the same, leave the rest. And so if you want to finish out the ones I circled, I think the only ones I haven't assigned verbally has been 48 through 58, I think, right there. And so finish those out. I know that's a lot of problems. You should do fairly well with it once you get the hang of it. You're just looking for what's the same. And then this is very important. So this kind of builds on itself, so make sure we get these done. The next lesson is fairly short, so it shouldn't be much time at all on it. So that's what we had today. If you have any questions, make sure you get up with me through the app and all that stuff. And we'll clean anything up we can. So hope y'all have a good day. Thank y'all for listening.